Hello students, I am Nilanjana Sanyal. Welcome you all to my channel Learners Online Math Classes. Our today's topic is solving simultaneous equations containing exponential and logarithmic equations. As we have seen in our previous session, we will be given simultaneous equations containing two variables x and y. So there will be two equations given and we will be having two questions in our today's session. The first question will be containing one exponential equation and the other one will be the logarithmic equation. And for the second question, we will be having two logarithmic equations. And we have to get the numerical values of x and y. Okay. So without any further delay, let us start with our today's session. First of all, we'll look at the question number 1 of this session. Solve for x and y. First equation is 4 to the power of xy equal to 2 to the power of x plus y, and the second equation is a logarithmic equation. It is log of y to the base 2 minus log of x to the base 2 equal to 1. This is the exponential equation. This is the logarithmic equation. You can take any of them first, but I have taken the first equation first. And how do you solve an exponential equation? The commonest method is to make the base the same for both the sides of the equal to sign and equate the powers. And for other methods, you can always check my math shorts on exponents, powers, exponents and indices. Okay, I'll be giving you the link in the description area, or I'll be giving you the links for one or two videos as cards as well. Okay, so you may check what are the other methods of solving exponential equations. But for this equation, we will be making the bases the same because 4 can be written as 2 to the power of 2. So this is 2 to the power of 2 whole raised to the power of x times y, which is equal to 2 to the power of x plus y. And using the power law of indices or exponents, a to the power of m whole raised to the power of n is equal to a to the power of m times n. So this will be 2 raised to the power of 2 times xy or 2xy. So this is 2 to the power of 2xy equal to 2 to the power of x plus y. Now since the base is the same for either side of the equal to sign, we can equate the powers and it will be 2xy equal to x plus y. This becomes our equation number 1. Now we come to the logarithmic equation. Log of y to the base 2 minus log of x to the base 2 is equal to 1. And always whenever we have to solve a logarithmic equation, what do? We try to get to a single term on the left hand side and a single term on the right hand side of the equal to sign. And so there is a single term on the right hand side. We will be combining these two terms to get a single term on the left hand side. It will be log of y over x to the base 2 equal to 1. And if we convert this to an exponential equation, it becomes y over x equal to 2 to the power of 1, which is equal to 2. Or y equal to 2 times x or 2x. Multiplying both sides by x, we get y equals 2x. This is equation number 2. Okay. So we have got the value of y in terms of x. We can substitute this value in equation number 1. So this is equal to 2 times x times, in place of y we have written 2x. So it is 2 times x times 2x is 4x square, and this is equal to x plus 5. So 4x square is equal to x plus 5, and if we add negative x, negative 5 to both the sides of the equal to sign, we get 4x square minus x minus 5 is equal to 0. This is our known quadratic equation. So first of all, we have to factorize this expression on the left hand side using the middle term splitting method. And these are the two linear factors that we have. 4x minus 5 times x plus 1 is equal to 0. From the first factor, x equal to 5 over 4, and from the second factor, it is x equals -1. But can we take both the values? Definitely not. We cannot take x equals -1 because we are having log of x to the base 2. And a negative number cannot be an argument of a logarithmic term. So we cannot take -1. We have to take only this value of x, that is 5 over 4. Okay, so we have got the numerical value of x as 5 over 4. Coming to the numerical value of y. Y is equal to 2x, or 2 times 5 over 4. This 2 and this 4 will get cancelled. So we have 5 over 2 as the final value, numerical value of y. X equal to 5 over 4 and y equal to 5 over 2. These are the two values of x and y that we are getting for question number 1. Okay, and because both are positive values, so we do not have to check. We can have positive values for base and argument. Of course, there are certain restrictions, means you cannot have 1 as the base even though it is a positive number. That restriction is there, but over here in this given logarithmic equation, you are not having any variable in the base position. You are having arguments as variables. Okay. So this x equals 5 over 4 and y equals 5 over 2. This is the final answer for our question number 1. Coming to question number 2. Solve for x and y. Log of y to the base x equal to 3 and log of x plus 1 to the base y plus 1 equal to half. Over here we are having two logarithmic equations. Again, you can start with any of them. I have started with the very first one. So it is log of y to the base x equal to 3, and I have converted this to an exponential equation, and I get y equals x to the power of 3. This is our equation number 1. Coming to this given second equation, it is log of x plus 1 to the base y plus 1 equal to half. Again, we convert this to its corresponding exponential equation. It will be x plus 1 equal to y plus 1 raised to the power of half. And since y plus 1 raised to the power of half is square root of y plus 1. And we do not usually want to have the square roots or fractional indices. So what we will be doing? We will be squaring both the sides. So we get x plus 1 whole square and equal to y plus 1 on squaring both the sides. And of course we will be expanding the left hand side, but in place of y we can write x cube from equation number 1, because we want to come to a single variable so that we can solve. So in place of y we write x to the power of 3 from equation 1, and the equation becomes x to the power of 2 plus 2x plus 1 on expanding this left hand side. This is equal to x to the power of 3 plus 1. And there is this plus 1 on the left hand side and plus 1 on the right hand side, which may get cancelled. And we may add negative x squared and negative 2x to both the sides. So we will be having x to the power of 3 minus x to the power of 2 minus 2x equal to 0. We do not know how to solve a cubic equation, but what we are seeing is that we are having the common factor x in all the three terms. So we take out the common factor x and it becomes x, and within parenthesis we have x to the power of 2 minus x minus 2 is equal to 0, and this is a quadratic expression. And we can factorize this part to get two linear factors rather. So we get the two linear factors as x minus 2 and x plus 1. So the entire left hand side is x times x minus 2 times x plus 1 is equal to 0. So the values of x that we get are either x is equal to 0 from this part, or x equals 2 from this part, or x equals negative 1 from this part. Okay. So out of these three values of x, can we take x equals 0? Definitely not, because we are having x as the base, and base of a logarithmic term cannot be equal to 0. Can we take negative 1? Definitely not. Base of a logarithmic term cannot be a negative number. Okay? Even if you take x equals -1, -1 plus 1, this will be 0. You cannot have 0 as the argument of a logarithmic term. Okay? So, because of these restrictions, the only value of x that we may take is x equals 2. Okay? These two should be rejected. So, we are having extraneous solutions. It is not written in the topic when I was reading the topic, I did not mention that there will be extraneous solutions, but we are seeing that there are extraneous solutions for question number 2. Okay? So, x equal to 2, what is the value of y? Y was equal to x to the power of 3. So, y is equal to 2 to the power of 3 or y is equal to 8. Okay? So, for question number 2, the final answer is x equal to 2 and y equals 8. Okay, y equals 8 because 2 to the power of 3 is equal to 8. So, students, this is how you solve simultaneous equations. Over here, we have taken only 2 variables. You can have, of course, 3 variables. That will be even more complicated. So, I have confined myself to 2 variables. Okay? And in your IBHL also, you will not be having 3 variable simultaneous equations containing exponential and logarithmic equations. So, it's better to stick to 2 variables. Okay? So, this was all for our today's session. Thank you for staying with me till the end. Please like, share and subscribe if you find this video helpful. We meet again very soon. Till then, bye.